Intermediate Algebra, Section 8.3, Studying Solutions of Quadratic Equations. It is sometimes enough to know what type of number a solution will be without actually solving the equation. Suppose we want to know if 2x squared plus 7x minus 15 equals 0 has rational solutions and thus can be solved by factoring. Using the quadratic formula, we have what's known as the radicand, the quantity underneath the radical, is known as the discriminant. And that is equal to b squared minus 4ac. It's known as the discriminant. This is the quantity that's underneath the radical in the quadratic formula. And from that, we can determine what kind of solutions we will have in our quadratic equation. If the discriminant, b squared minus 4ac, is equal to 0, it means that there is one repeated solution and it is rational. So in this example, without actually solving this, if we just determine what kind of solution we get, we'll determine the value of b squared minus 4ac from a being our leading coefficient, b, which is 6, the coefficient of x, and c is our constant value. We end up with b, which is 6 squared, or 36, minus 4 times a times c, which is 1. Well, 4 times 9 times 1 is 36. 36 minus 36 is giving us a value of 0. That means we will have one repeated solution and that it's rational. And actually, if we went through and solved this then, whether we factored it or used the quadratic formula, we would end up finding x is equal to a negative 1/3 2 times. That's sometimes known as a double root. If our discriminant is positive, it can be one of two things. We will have two different real number solutions. Either they'll be rational or they will be irrational conjugates. And let's look at this equation to show an example of that. Again, without looking at the nitty-gritty details, if we just want to know the nature of the roots or solutions, we'll determine the value of the discriminant. Here a is 6, b is 5, c is 1. Plugging that in, b squared, in other words 5 squared, will give us 25 minus 4 times a, which is 6, times c, which is 1. 4 times 6 times 1 is 24, and 25 minus 24 is going to give us 1. What that tells us is that because it's positive, and think of where the discriminant is in the quadratic formula, it's underneath the radical. Taking the square root of 1 is 1. It's a perfect square, and so that means we'll end up with two rational roots here. And if we wanted to go further, the actual solution to this equation is x is equal to a negative 1/3 or a negative 1/2. In this other example, looking at the value of the discriminant, we have a is 1, b is 4, c is 2, and if we determine the value of the discriminant here, we would have b squared, 4 times 4 is 16, minus 4 times a, which is the 1, times c, which is the 2. We would have 16 minus 4 times 1 times 2, which is 8. 16 minus 8 is 8. And again, think about where this discriminant is located in the quadratic formula. It's underneath the radical. A square root of 8 is not going to give us a perfect square. And so in this case, we would end up with irrational conjugates. And as a matter of fact, again, if we did solve completely, we would find that the solutions are a -2 plus square root of 2, and another solution, if I use subscripts for the different roots, we would end up with its conjugate, -2 minus square root of 2. The other possibility for the discriminant, besides being 0 or positive, is that it can be negative. If the discriminant turns out to be a negative number, it means that we will end up with two different imaginary numbers that happen to be conjugates of one another. And to illustrate that occurrence, here we have another quadratic equation where a is 1, b is 4, c is 5. Let's see what the discriminant value would be. So we'll take our b and square it. So 4 squared is 16 minus 4 times a times c. We end up with a 16 minus 20, which leaves us with a -4 when we simplify. Clearly our discriminant is negative. It means in this equation we have two imaginary numbers. When it comes to graphing, this would mean that our parabola, the equation of the graph of this equation, would not intersect the x-axis, and we'll talk about that in a future section. But if we wanted to now continue on and actually find the solutions, as it turns out, x is equal to a -2 plus I or a -2 minus I, and there you can see the conjugates of each.